Okay. So when we talk about prescribing aerobic exercise, okay, prescribing aerobic exercise, what we need is we need a way. We'll see this when we practice today. We need a way to prescribe intensity. Okay. That's going to be the thing that's the most difficult for all of us to do. Is if I was to tell Kaylee, go run. Okay, we want to adhere to the FIT principles. You're going to go run today. Your first question should be, that's great, Dr. Black, how fast? Right, I can tell you go run for 20 minutes or go run 2 miles, but the really important thing is, how do we know how fast you need to run? Or you're going to go to spin class, okay? And I was looking at programs for spin class this morning, and I was appalled at some things that I was on. You're going to go ride a bike, and the whole thing is going to be, how fast are you going to ride the bike? What is the resistance setting on the bike need to be? Okay? So the thing that we need to make sure that we pay very close attention to and that we deal with properly from a prescription standpoint is the intensity domain. Okay? So, all right, let's do this. Madison, either Madison, we'll go cheerleader Madison. Freezing. Stand up. We do 5 jumping jacks right now. 1, 2, 3, 4, 5. Y'all see people do jumping jacks in your rain boots? Okay. What is your VO2? So the ideal way to prescribe intensity is we need you to be at some percentage of your VO2 max. What is, as we sit here, what was Madison's percentage of VO2 max? Anybody know? No, we don't know. No. How would we know her VO2 max? Think about what we did on Monday. You may sit down. Thank you. What do we do? What do we talk about on Monday? How would we know somebody's VO2 max? Okay. Kevin, if we wanted to know Madison's VO2 max, how might we arrive at that answer? What could we have her do? We could run them out, but we could do a test. We're going to test it, right? So if we want to ideally prescribe intensity as a percentage of your VO2 max, we have to first know your VO2 max. Okay? Not the easiest thing to do. Once we know your VO2 max, okay, by this time next week, we will know approximately everyone in class's VO2 max, or you're going to fail one. Okay? We'll know everybody's VO2 max, or a rough approximation. Okay? Even if we knew Madison's VO2 max, by having her do jumping jacks like I did, that's still what else we have to know what percentage of her max she's at. We have to be able to measure her oxygen consumption while she's doing the jumping jacks. Not really very feasible. So we have to know your max, and we have to have a way to measure VO2 during a given bout. You're going to go run, we got to measure your oxygen consumption while you're running. I ran yesterday over at the Huff. I was like the only person in there. I don't know what my VO2 was. I don't know what my max is. I don't want to know. And there was no way for me to know kind of what all was going on. Okay. So this is the best way to do all of this. All right. It's the best. It's completely infeasible. We can never actually do this unless you're going to come down to my lab or go to Dr. Beller's lab or go to Dr. Mike's lab, one of our places like this. Okay. So from a theoretical standpoint, this is the best thing to do. We're gonna test your VO2 max. We're gonna measure your oxygen consumption while you're doing a certain thing. And we're gonna say you're at 60% of your VO2 max. We know that's going to be sufficient to make you get better at doing such and such. Okay, That would be a thing that we can do. We never do, right? So in the absence of doing that, in the absence of having the ability to do that, what we're going to do is we're going to look at something called heart rate reserve. That is much easier for us to measure and assess, much more feasible to be used while a person is actually exercising, okay? And will be, again, a rough approximation of the exact same thing, okay? In the absence of doing heart rate reserve, people have used a percentage of your max heart rate. It's not great, but again, it's better than nothing, right? If you know what your max heart rate is, there's no reason to ever use this. If you can assess your heart rate, then you want to use this version of it. Okay, this is wrong. And then if you can't measure these things, then we can use something called rating of perceived exertion. You guys ever seen the Borg scale, the 6 to 20 RPE scale, or the 1 to 10 RPE scale, or something? It's basically a way. It was originally set out, and it scaled 6 to 20, not because the guy was a weirdo or anything else, because he didn't have a clue, but it's meant to track heart rate. Okay? 6, you guys are all at a 6 right now as you stare at me and want to take a nap. Okay? No exertion, no effort whatsoever right now. Okay? 6, resting heart rate of about 60 beats per minute. Okay? You go up, it goes from 6, about a 9 is what we call very light. A 9 is walking. Okay? You guys can walk. If your resting heart rate's about 60, you're walking, it's probably about 90s. Max heart rate in college age folks is 200. We'll look, it corresponds to the 20. Okay? So the Borg scale is like no effort, light effort, and then there's moderate effort, and then it's like somewhat hard and very very, very hard. And it's meant to just kind of encompass how hard or how much effort you have to put in trying to do something. Okay? It's a lovely scale. Okay? The problem is people are unreliable narrators, right? You lie to us and yourself. Okay? We will tell people in lab, oh, look, here's how the scale is anchored. 6 is nothing. 9 is walking. Not breathing hard, you're just having a nice leisurely walk. 20 is chased by a velociraptor. I don't know, whatever it is that terrifies you. Okay? Chased by the zombies from World War Z, the ones that can go really fast. Whatever. Right? That's those things. Put them on the bike. They're doing we'd be doing our VO2 max estimation protocol. They're breathing hard. Their heart rate's like 160 beats per minute. They're about to have to stop. And they're like, no, my RPE is 7. I'm like, no, it's wrong. It's not a 7. It may be not 20, but it's not 7. So this is hard to use. My point is just, if I ask you all, imagine how hard was it for you to do this something? How hard were you trying? Not very hard. Any more than you would if you were just walking around or anything, probably. Maybe a little bit more because of the boots. Okay. So maybe she's at like a 10 or an 11. Okay. We have no idea what her heart rate was. It doesn't actually correspond to a physiological measure. And so what you think of as hard is determined by your past history and a whole bunch of other different things. Okay. So this is better than nothing, but again, we're going to focus here. Okay. We're going to focus on something called heart rate reserve. So let me see if I have the actual equation in the next. Okay. So the first way that we're going to need to do in order to calculate a percentage of your heart rate reserve is to calculate your max heart rate. So everybody do this with me, okay? Get out your piece of paper on your notes, type this out, write this down, do this with me, follow along, okay? Here is our classical equation to estimate max heart rate. I want to know heart rate reserve, or HRR. First thing that I need is to estimate max heart rate. Okay? So we're going to do 220. We're going to subtract my age from all of that and so for me, my max heart rate is, right, that math right, yeah, 177 beats per minute. Okay? 177. Now, luckily for me, maybe, this equation tends to underestimate max heart rate with increasing age, especially if you're older and you're still very well trained. Okay? I am not that old, nor am I that especially well trained, but maybe it underestimates a little. It's really good in you guys. Okay? So all of you guys do this. All right? 220 minus your age. I'm now going to see, as I repel my technology, on the watch. It says that my Apple Watch will tell me my resting heart rate. If you guys have one, you can do this. It says that my resting heart rate is pretty hilarious. You can look back. I can see where about 5 a.m. was on things when I put it on, because I knew I was going to do this today. You can see it spike up to like 100 as I'm running like up and down our stairs at our house. So it says the next thing that we need resting heart rate. Okay. This thing says my resting heart rate is 70 beats per minute. Okay. If you don't have an Apple Watch or a Fitbit or some other kind of wearable device that will tell you what your resting heart rate is, you can sit there, put 2 fingers on your carotid artery, and get your phone out, time yourself for 15 seconds, count, and then multiply by 4. Okay? We get a rough estimate by doing that. So my max is 177, my resting heart rate is 7. Okay. Now there are newer equations for calculating max heart rate. I don't know, Dr. Bellers, do you have any experience with these things? I've never ever used them. Again, it's some dumb shit that we do because we're scientists and we're never happier than when something that works well gets made more complicated. So it's 207 minus 0.7 by your age. And if we do all of that, I'll do the math real quick for myself. And then let me see here. Okay, so I'm 43 times 0.7 equals that minus 207. Shockingly, using this equation, my max heart rate is still 177. Okay, I don't know. Let's try the other one. Take 43 times 0.64 minus 211. Okay, then it says it's 1. This one tells me that mine's 183. So we're within a couple of beats. It's all about the same. Okay. So don't really worry about those. You need to know this one. You need to know 220 minus your age. I should also mention what we're about to do next when we calculate heart rate reserve and then find a percentage of it to prescribe a heart rate during exercise will 100% be on the test. Okay? 100% is going to be on the test. So just try to pay attention. Okay. So the next thing that we're going to do, okay, is this. Okay. I need to calculate heart rate reserve, and then I got to figure out how we're going to pick out some percentage of that to prescribe exercise. So heart rate reserve is equal to max heart rate minus resting heart rate. Okay, so I'm 177 minus 70. Okay, my heart rate reserve is 107 beats per minute. 107 beats per minute. So what reserve is attempting to get us, okay, is how many beats per minute of heart rate do I have available to over rest to be able to increase before I reach my max, okay? So a person that has a lower resting heart rate has a larger heart rate reserve. If you guys have the same resting heart rate as me, you all will also have a larger heart rate reserve because your max heart rate is high. So, okay, that's how these two things are going to work in concert with each other. Okay, so my reserve is 107 beats per minute. What we know, and I apologize that I didn't put a graph about this in, but okay, if we prescribe exercise that if you exercise at a percentage of heart rate reserve, that roughly approximates that exact percentage of VO2 max. Okay, so if I'm at 70% of heart rate reserve, that means I'm also at approximately 70% of VO2 max. Okay? So if we know what the heart rate needs to be in order to be at 70% of my heart rate reserve, I can tell you, you're going to go run, and I want you to run fast enough to get your heart rate to that particular point and then stay there. Okay? And if you go over time and it begins to creep up, then you can slow down. If over time it begins to fall back down, then speed back up. Okay? So here's where this gets a little bit tricky. All right, here's where it gets a little tricky. So let's say, all right, for the purposes of what I have written here, okay, I've taken what I think is roughly a pretty common thing for someone that might be y'all's age. We've got a person that's 20 years old, so they have a max heart rate of 200. Okay? They've got a resting heart rate of 60. We want them to be at 70% of their heart rate reserve. So to calculate your target heart rate, we're going to do something that's called the Carbonin method of estimating target heart rate. So what that means is calculate heart rate reserve. This person has a heart rate reserve of 140 beats per minute. 200 minus 60. Okay? We then take 70% of that. So 70% of 140 is what? Who knows? I'm sorry? Let's work on it. That's 98 beats per minute. So if I told you to go exercise at 70% of your heart rate reserve, and that 70% is 98 beats per minute, what you don't want to do is try to go run and have your heart rate at 98 beats per minute. Okay? Don't get that twisted. Okay? Your reserve is this theoretical amount that you have available to you above rest before you get to max. So we need to access 70% of that reserve. So we need to access almost 100 beats per minute. But then to know where we need to be during exercise, we have to take our resting heart rate, which was 60, and add, okay, that 98 on top of it. So it's rest plus 70% of the reserve. So that would give us a heart rate during exercise of 158 beats per minute. So if I told you I want you to exercise at 70% of heart rate reserve, and you're 20 years old and you have a resting heart rate of 60, you need to go and run until your Apple Watch tells you that you're at 158 beats per minute. Okay? That's your pace. All right, that's your pace. The reason why this is better than the old way of doing it by using a percentage of your max heart rate is that if I took 70% of max heart rate, I'd only be at 140 beats per minute. The max heart rate way tends to dramatically underestimate your target heart rate. Therefore, using max heart rate, the percentage of max heart rate rather than heart rate reserve, really limits your overload to drive your adaptations. Okay. I'm sure that there's some parts of this that are unclear. There always are. How can I be helpful? We need to do it differently. Do you guys want to work through a different one in order to see how this goes? Okay. Lauren says yes. Allie's nodding her head. Are the rest of y'all alive and awake? Or are you just frozen popsicles because it's freezing in here? It's very cool. Okay. We're going to do another one. All right, we're going to do another one. So, would anybody like to share your information with us? Or do you want me to just make someone up? Okay.
My resting heart rate is 66.1.
Okay, that's too close. All right. I appreciate you wanting to shoot. So your max is what? 200, 199? Okay. 200, and it's at 62. So if we did 70%, yours would be, it would be really, really close. So we'll just take mine, okay? My resting was 70. My reserve was 107. Let's say I don't want to do much today. So I want to go be at 55% of reserve. See if you guys can figure out what my number should be. Okay? What should my number be? Okay. Somebody here think you have it? Think you're close? All right, we'll do a fun game. Randy, come write the number that you got up on the board, and then we're going to ask somebody on Zoom if they got the same thing.
What if it's not?
That's okay. That's okay. Okay.
Anyone else get that? I did. Okay, good.
Okay, somebody just pieced out on Zoom. They're afraid we're going to call them. Let me just pick somebody. Let's do this. Taylor, are you there? Okay, try again. Vale, are you there? Vale's under.
Yes.
Okay, what number did you get, Vale?
I'm still calculating it. I was trying to grab my phone so I could do it.
That's okay. We'll wait on you. Oh, Cameron wants the numbers again. All right, so my resting was 70. My rate reserve 7. riveting class time.
We need a space here.
Okay. Those are outlawed. We're not allowed to have those.
I didn't really.
Even though if you were to go to my office, guess what's in my office? Dr. Vellers, do you have a space heater in your office?
No.
Of course you don't.
But my
I
dad-
think all of us have one,
my
because
dad-
it's freezing.
my
Ooh,
dad
all right,
has a-
so Daniel says 141 and a half. Daniel, that is not correct. Vale, how we doing? Cameron says 140.5.
I got like 90.35, but I know that's not right. So I think I did something wrong.
That's okay. Emma has it. It's 129. 129. Okay. So Cameron, what did you do to get 140? You're using an iPhone calculator. I used my iPhone calculator and it did okay.
Did you plug it all at once, or did you do it step by step?
No, I did it. What?
It's like it doesn't give the order of functions right sometimes.
So here's what I would suggest that you guys do, okay? Because I'm also bad at math. That's okay. That's all right. So the way to do this, calculate reserve first. Do this part first. Do it separately. So I just know my reserve is 107. I took that and multiplied it by 0.55, so I got 55% of it. And then I just say, add that number on, add 70 to that number. Okay, that's the pretty straightforward part. If for whatever reason, you've got to go in, you got to calculate reserve first, right? You got to know their age, you got to know their rest, you got to do that part first. Then yeah, your order of operations becomes really important in trying to put all of that in. So you just do this plus this minus this, then shit gets crazy. Okay, so no worries. We'll practice this again, but you will have to do this on the test. I would argue you should do this every time you go and exercise, right? You should figure out what is it that I'm doing. Okay, Madison.
Will we get a calculator?
On your test?
Yeah.
Sure.
Like the percent.
Yeah, absolutely.
Okay.
Yes. I mean, it would take a lot of doing for you guys to somehow like load all of your notes and the study guide that I know I haven't posted yet. That just occurred to me. Okay. To put all of that on your phone and be able to like look at it for like 3 seconds and somehow access everything. So you can use your phone on the test. You will have a calculator. We have caught people cheating with their phones in previous classes. A person, not in my class, but in another one, had set on their phone. And they sort of, and this is kind of crass and terrible, but they kept looking at their crotch. And it was down there, and then, you know, those kinds of things. And so as it turned out from one of our faculty, so usually what I will do, which we did the other day, is I'll be like, take your calculator out, set it on your desk, or put your phone on your desk where I can see it, or wave it at me, and then very sort of with a flourish, put it in your bag. I don't want to go around having to worry about what you're sitting on or anything else. I don't want to do that. It's not worth it to me. Y'all want to cheat that bad, then I suppose knock yourselves out. I'm not doing it. So, yes. Long story short, man, you have a calculator. All right. So, sorry, I'm just a little salty today. I don't really know, and I know why. I've been up since 5.
What's that?
So, one thing. That's twice in like 2 years that a tornado has basically come over our house. Never in my life have I been close to a tornado. Twice since my daughter has been born, we've had to sprint her into our basement.
How long have you lived in Oklahoma?
Since the fall of 2013.
Wow, does it have any place?
In my second year here, I was teaching capstone in the spring, and it was during finals period, and I was the only adult in the building, and there was a tornado in Norman. And so I had to like try to lock everybody in the building, and like everybody used to go downstairs and hide. They're like, you can't keep us here. I want to leave, right? Vaccine mandates all over again. I want to go see the tornado. If I want to kill myself, it's my doing. So I was like, all right, fine, you go outside. I can't keep you here. But anyway, crazy. So, okay.
Don't you ever walk outside and just see all the native Oklahomans coming out when this is tornado warning?
I'm aware that it's a thing that does. People get in their cars and like drive after them. It just seems dumb. Why are we courting death? Right? That probably explains my stance on the vaccines and the mask and everything else. I'm just like, no chances. No chances to be taken.
If you understand tornadoes well, you can drive really close to them and not get hurt.
I appreciate that you want to be on the southwest side of them and you're behind. They kind of go. I've seen the TV shows, Lauren. I've watched Storm Chasers a bunch. Where's Reed in the freaking Tornado Dominator or whatever that car was that he had? I've seen the shows. I know. But I'm just very averse to anything that can cause me harm. All right. So let's talk, and then we'll come back and we'll do some prescription stuff. Okay. Let's talk about what changes. So we know how to test to try to assess what your maximal aerobic fitness is. Okay. Let's assume we've done that. Let's assume you've done some 8 or 12 week prescription program. You've followed FIT. You've followed PROS. You're using a target heart rate to train every day based upon your heart rate reserve. You're doing great. You're doing everything perfectly. Okay. In 8 weeks or 12 weeks, what's going to have changed? All right. Well, what we know is that in general, this doesn't count for everybody, but most people will be able to increase their VO2 max in 8 weeks, 12 weeks, 16 weeks, somewhere between maybe 10 and about 40%. Okay. Just like with strength and muscle mass, though, with resistance training, some of you, the research tells us, will train perfectly and your VO2 max will never go up. Okay. Some of you can train very poorly and your VO2 max will go way up. Okay. In both of those instances, Dr. Vellers would like some of your blood to test your mitochondrial genetics. Just my prediction. Okay. A lot of this, remember, a quarter to almost a half of your ability to change is due to genetics, but most people can increase in this range. Okay. Increase in this range. So you're an average college-aged woman. Your VO2 max is 35 mLs per kg per minute. In 8 weeks or 12 weeks, let's just say you're probably going to be at 40 or 41 or something like that. You're an average college-aged guy. Yours is 40. You train for that amount of time, and you're going to be in the mid to high 40s. Okay? Some of you can train, it will go way up. You're at 35, and it might have the capacity to go to 50 or 55 or 60. Okay? It's just going to depend. So the more important thing to me, or the more interesting thing to me, is not the amount that it goes up. It's what's going to change. What's the physiology that drives VO2 max to go up? Okay? And so just kind of a quick rundown of some of those things is one of the big drivers is that the mitochondria in your skeletal muscle will double. Okay? It will double. So you now have twice as much of a capacity to make energy using oxygen. Okay? Now, VO2 max isn't going to double, so obviously this is not the only thing that's doing this, and there's going to be some other places where we're going to be limited. But you get more mitochondria. That's good. You get more capillaries. Okay? So I have mitochondria. It does you no good to have more mitochondria if you can't bring more oxygen to those mitochondria. So you get more capillaries. Okay? You get more blood, and you're going to get a bigger heart. Both of those things are going to make your stroke volume go up, and that increase in stroke volume is going to make your cardiac output go up. Okay? So I get cardiovascular adaptations that let me bring more oxygen to my skeletal muscle, and I get mitochondrial adaptations that allow me to use more of that oxygen that the cardiovascular system brings in skeletal muscle. And the end point of all of this is VO2 max goes up. Okay? From a very practical sense, what this means to you, okay? What this means to you is if I go and I run on the treadmill at 6 miles an hour, it feels easier, okay? As you become more trained, as your VO2 max goes up, any running speed, any setting on the cycling bike, any resistance begins to feel easier because it's going to require energy expenditure that is less or a smaller percentage of your maximal capacity. Okay? So we would do, I think I told you guys on Monday, that a few years ago, we did VO2 max testing on some of the guys and girls that are on the distance runners on our track team. They would come in and warm up on the treadmill at a speed that is faster than I would reach if you were putting me at max. Okay? Because their VO2 max is like twice what mine is. They're just like, whatever, this is fine, this is easy, this is comfortable. And I'm like, I hate all of you. Right? It sucks to be old. But that's kind of how this practically comes into play. So that's how you're able to learn how to run faster. Not learn, but you're able to run faster. Your mile pace time or your 5K running time, your marathon time will become faster because you can go at a faster speed, and that any given speed is a lower percentage of your max. Okay? And as we get closer and closer to max, we're going to get fatigued. Okay? It's much more complicated than that, but that's kind of the general gist. Right? Okay. So a little more detail on these things. Here are mitochondria that are in your muscle. You can double the number that you have. You also can tend to increase the size of the ones that you have, and you may even be able to also increase the kind of health or efficiency of those mitochondria. That's less of an issue in you guys. Y'all generally work pretty well when you get to be like my parents' age. Then you may have some raggedy ass mitochondria that don't work very well. Okay? So, because you have more mitochondria, you have more Krebs cycle enzymes, you have more electron transport chain components, right? You have more cytochromes, you have more ATP synthase enzymes. This change, this increase in mitochondrial content occurs in all muscle fibers. In some instances, it occurs to the greatest extent in type 2A muscle fibers. Okay? And so you can get better. This is one of the reasons why I can take every one of you, okay, regardless of your fiber type, regardless of how trained you are now, I can make every one of you a better distance runner. Okay? I can improve your endurance capacity. I can't make many of you better sprinters. There's just not a lot of room to train people in that way. Because the things that make you a sprinter, it's much more difficult to change and train than this. Okay? So your mitochondria are going to build. You get more mitochondria. All right. So we talked about that. We talked about capillaries. Let's talk about blood volume really, really quickly. Okay, so this is one that I don't think gets a lot of attention, but it's really, really important. The more you run or bike or elliptical or whatever it is that you're doing, then you're going to stimulate, okay, you're going to stimulate red blood cell synthesis, and you're going to stimulate an expansion of your plasma volume. Together, what this means is you have a certain amount of blood, you're going to get more. Okay, you're going to get more. As you get more blood, there's more red blood cells. There's more places for oxygen to bind in the lungs. There's more blood to bring that oxygen to your muscles. In addition to all of that, having a larger blood volume can make stroke volume more. So I can carry more oxygen, and it makes my stroke volume more. These are both going to be good things. Now, when you take exercise phys with Dr. Mike, y'all will get into the time course that plasma volume goes up. Like you run today, plasma volume goes up tomorrow. It may take a couple of weeks for red cell content to begin to kind of catch up and increase. And then the plasma volume can go up really, really quickly. One of the ways that this happens, especially the plasma volume thing, is something that I have termed a persistent acute effect. Okay, so you go run and you increase your blood pressure, you drive plasma, you drive water from your blood into your muscles, which is why you feel like you got a pump and you're all swelly, and it all goes away. What that does is it leads to an increase in antidiuretic hormone and aldosterone. In human phys, you guys talked about renal function and how the kidneys work and all of that. Okay. Your kidneys play a huge role in regulating blood pressure, and they do so by regulating urine output and therefore plasma volume. Okay. So what happens is, as your plasma volume dips a bit because it gets shoved into your muscles, then it looks like you're dehydrating yourself, and so you're going to release ADH and aldosterone, and through different mechanisms that we're not going to talk about. If I say like distal convoluted tubules, we all throw things at me and all of that. Yes, like if you remember enough from human phys in the midst of that, the glomerulus, right? All of these things. But the effect of both of these hormones is that we're going to overcompensate after exercise, make less urine, and make you thirsty. So you're going to want to drink enough fluids. Okay. The net effect of this is that for a couple of days after that bout of exercise, this is this acute effect, the increases in these hormones lead to an expansion of plasma volume. You make a little bit less urine, you want to drink more fluids, so you're going to hold on to more water, so your plasma volume goes up a little. Okay. If I exercise today, I get some of this. I exercise tomorrow, I get some more of this. I take a day off, it lasts about 2 days, so I'm still okay, and then I exercise again the day after that, more acute effect. So it's this persistent acute effect. All right. So as long as you're doing something every couple of days, you will begin to increase and maintain this increase in plasma volume. And therefore, that will also then stimulate an expansion of your red blood cells. If you stop, it goes away within, a couple of weeks. It all goes back down to kind of what your baseline was. It will go away very, very quickly. So this idea of a persistent acute effect, we'll also see this with some other things that go on. Part of this is going to be helpful with our blood pressure response to exercise or our changes in blood pressure after exercise. It's really a similar kind of thought. The persistent acute effect when we look at changes in insulin sensitivity in people that are type 2 diabetics after exercise. That's kind of what else. Okay. So I told you guys that cardiac output goes up. It only goes up because of a change in stroke volume. Okay. You train all you want, your max heart rate doesn't change. In some instances, it actually goes down. Okay, it actually goes down, which isn't great for cardiac output. Right? What we do see with heart rate, though, is that at rest, it's going to decrease. At any given absolute work rate, so running at 6 miles an hour, doing the elliptical on a setting of 8, whatever it is, your heart rate at that work rate is going to tend to fall. Okay? And so what happens, what that means is if max stays the same and resting falls, Adriana, what would we think would happen to my heart rate reserve? Max is the same, resting falls, what happens to heart rate reserve? Exactly right. It gets bigger. Very good. Okay. So one of the consequences of training, because resting falls, is your heart rate reserve gets bigger. Okay, so that's good. You've got a larger range to be able to increase before you reach your max, which is also one of the things that contributes to possibly increasing performance. Resting heart rate falls because of increased parasympathetic input to the SA. Okay, that's what happens. As you get adaptations, your left ventricle gets bigger and your stroke volume goes up, then you don't have to beat the heart as many times in order to get the same cardiac output that you need at rest, and so parasympathetic. Okay. Stroke volume, on the other hand, is going to increase. And it goes up because left ventricular volume especially will increase. So we'll see cardiovascular hypertrophy because of that. Because of that, we're going to get, and the heart rate falls, we get increased filling time and increased venous return because we're increasing blood pressure. So this then, max heart rate is the same, max stroke volume goes up, therefore max cardiac output. And that's how we get a bigger cardiac output. More blood, more red blood cells, and a greater capacity to circulate all of that. Plus I have more capillaries and more mitochondria, so I can diffuse more of that oxygen into my muscles. And the end result is that more oxygen gets in, more oxygen gets to the muscles, and we make more ATP. And that lets us run faster, cycle at higher power output, et cetera, et cetera. That's why you get better at doing these things. That's how you become a better endurance performance person. None of this matters to you guys right now for anything you do in your daily life outside of maybe Madison. Or other things in your daily life really don't matter. Like you get up and down stairs, you've got plenty of VO2 max to do that. Some people don't. And so the ability to increase mitochondria, increase capillaries, and change heart stuff is good because people that are post-heart attack, we can have them exercise like this and their VO2 max will go back up. Okay? We can get some other adaptations in people that have pulmonary limitations and maybe raise it up a little bit. Okay? So for you guys, this stuff doesn't matter that much because most of you don't care about running the Boston Marathon in under 2 hours and 20 minutes or something. But in some older folks and some people that have pathologies, it matters a lot. Okay, so let's look at this really, really quickly, kind of before we jump off here at the very end, okay? So there are, with aerobic training, there are some acute, kind of very fast changes, right? Things that are going to happen after one or possibly, a couple of weeks of exercise training. Blood pressure tends to fall. Blood glucose and insulin sensitivity tend to go up. Plasma volume tends to go up. These things are all in some ways related, okay? Chronic, slower ones, it takes several weeks, maybe a month for us to see a measurable increase, a truly meaningful and measurable increase in VO2 max. Blood cholesterol levels, mitochondrial levels, capillary levels, those things may take a little bit longer period of time for us to try to get out. Okay. So, and many of these things are stuff that we can measure in my lab, in Dr. Beller's lab, and Dr. Larson's lab. These are things that we're very interested in trying to understand. So we know, okay, some things change fast, some things change slow. Is there a way for us to change how we're training to make some of these things happen faster or to make these acute things stay around longer? Because there may be some real health implications. That's just kind of a graphic way. So we'll try to finish today, before we do our exercises, by talking about ways that we train, modalities that people use to train. Okay? And this has gotten a lot of attention into the last 10 years or so, a lot of attention. The very traditional way, if I told you guys, right, we're going to go off and we're going to go do aerobic training today. We said, Phoebe, you're going to go train today. The most likely thing she would tell us that she's going to do or recommend that you do is what is sometimes called longer, slower distance exercise. Okay? What that means is you're going to go jog at a relatively moderate intensity. Maybe, I don't know, somewhere around 60% of your VO2 max, your heart rate reserve. And you're going to do that for 20 or 30 or 40 minutes or an hour or something like that. I'm just going to go jog for a while. Okay? Or I'm going to ride the bike at something like this for some longer period of time. Okay? This oftentimes was done at a duration that is greater than what we would expect for if you're doing some kind of competition. Okay? If you're competing in a 5-kilometer race that you're going to run, it takes you 20 minutes, then you're probably going to go and run for 30 minutes or 45 minutes or something like this. Okay? This is based upon the idea that improvements in mitochondria and cardiovascular variables are based upon the volume of training. Okay? It's intensity by days per week by minutes of training. The bigger the volume, the more overload we're going to get. Okay? And this is a reasonable thing. This works. Okay? This works. We know that as long as you're over about 50% of VO2 max, okay, up to 40 or 45 minutes, up to 5 days per week, you can do these kinds of things, and you'll get increases in VO2 max in that 10 to 40% range. It's about what we would expect. Okay, this works. Problem is, I don't want to go run for 45 minutes. I don't have time for that shit. Okay, I got other things to do. I got grad students that need things. I gave you guys assignments that y'all need graded in those things. All right. So we've looked into, are there other ways to approach a lot of this? And so one of the big things that people look at now, it's gained a lot of attention in the last 10 years, is something called interval training. Okay, interval training. Interval training involves repeated bouts of exercise in one exercise or one training session. I do something and I go at a higher intensity and then I rest for some period of time and then I do it again, right? So I'm going to go over to the huff and we're going to run one lap around the track as fast as we can. Okay, then we're going to walk a lap. And we're going to run one lap as fast as we can. And we do that kind of, that would be called interval training. Okay. Generally, interval training, when you are going at that higher intensity, you're going to be at somewhere between 85 to 100% of your heart rate max, heart rate reserve, or VO2 max. Okay. So there's one thought of interval training where you're gonna do things that last longer than 60 seconds. Okay. So that's kind of moderate interval training. We also have things out that's called high intensity interval training. It's much briefer than all of this. But you work at a high intensity, you go for a minute or two, then you do some rest interval that takes about as long or a little bit longer than what your work session was, and you do these things kind of repeatedly over the course of your session. Your total session is shorter than, say, a half an hour or 45 minutes. I'm going to be over there for 20 minutes. I'm only going to spend half that time actually doing something that's not walking. Okay. So I'm going to run really hard for a minute, walk for a minute, run really hard for a minute, walk for a minute. I've been there 20 minutes. What we know is if you do things like that, within some reason, you get exactly the same adaptations that you get from the long, slower distance training. What it highlights, I think, is something that I think everybody knows intuitively. It's intensity. That's the primary driver of all of these adaptations. Just like with resistance training, it's how much weight you're lifting that drives things. With aerobic training, it's how hard are you working, right? What is your running pace or cycling power output or whatever else? It's better to go hard for a shorter period of time and then rest a little bit and then go hard again than to just, like go walk for an hour. I think everyone intuitively understands that. But this is kind of a more formal way of trying to look at that. There have been literally thousands of studies trying to determine what is the optimum interval, intensity, work period, rest period to evoke the best changes. Okay. I borrowed this graphic from a guy who has written a book. It's called the 1 minute workout. He's a professor at McMaster University Masters in Toronto, I believe, in Canada. He's a very famous exercise physiologist. His name is Martin Jabala. But this here in the blue is, they're calling it moderate intensity continuous training. So you're going to go, right? I'm at like 50% of my peak power output on the bike or 50% of my max running speed, and I'm going to go for like a half an hour. Okay, it's constant. Here is this kind of higher intensity interval training, this kind of moderate intensity interval training where you do these bouts where I'm at maybe 75 or 80% of max speed or max output. Then I rest a little bit, then I do it again. So it's kind of work, rest. Then they have these things that they call sprint interval training. Most people that talk about interval training now, this is what they do. Okay? I'm going to kill it for 8 seconds or 10 seconds or 30 seconds and then rest for a couple of minutes and then kill it, okay? And do these kinds of things. What they have done is they figured out first, you do a 30-second all-out sprint and then you rest for 2.5 minutes, do a 30-second all-out sprint, do that 5 times, and in 6 weeks, you get the exact same changes that you get from doing 6 weeks, 4 days a week, 60% of the max training. Okay? Then they dialed it back and they said, let's do 20 seconds 3 times. Okay? If I told you guys all you're gonna do today is you're gonna go and you're gonna do 20-second sprint on the bike, go as hard as you can for 20 seconds, rest for 2 minutes, do 20 seconds, you can do it 3 times. Okay? 1 minute of actual work. Okay? Like 8 minutes total spent on the bike when you work out today. Think you could do that? That seem reasonable to you guys? Okay? Do that 3 times. Same adaptations. So you get from everything else. Now you got to crush it for that 20 seconds. They tried it at their dorm and had people, we're going to go over to Walker, we're going to sprint up the stairs, okay, for 20 seconds. Then we're going to walk. We're going to sprint up another couple flights of stairs for 20 seconds. They did that 6 weeks, same effects. Let's point out and run. Okay, that's where he gets this idea of the 1 minute workout. You do 3 20-second all-out bouts. Okay, that's all you got to do. You get relatively similar kinds of things. And the thought is, everybody's got 8 minutes or 10 minutes or whatever in your day. If you take that, you don't like the 20 seconds you're doing this, but it's not long enough that it's so unbelievably terrible. Okay, that's kind of the idea behind a lot of these things. So if you see something when you're looking for your aerobic training program to critique, where they're talking about sprint intervals or high intensity intervals or something like that, this is kind of what they're talking about. Okay? Anybody done CrossFit? Ramsey's the only one willing to acknowledge it. Okay? Interval training, right? You got your workout of the day. We're going to do as many things as we can in 2 minutes. As many push-ups as you can get in 2 minutes. Other days that you got to do 200 push-ups. It takes us long, do them as fast as you can. They kind of flip things up. But again, the idea behind those things are work hard, then rest. Work hard again, then rest. Okay? The harder, the higher the intensity, the shorter the amount of time you can actually maintain that intensity, the shorter amount of time you have to work. Okay? Anybody done Orange Theory? Anybody been to Orange Theory? No? Nobody does Orange Theory? Okay. Well, Orange Theory, you wear a heart rate monitor. They track your heart rate. They want you to get into these heart rate zones, okay? That are just percentages of heart rate reserve based upon your age and your resting heart rate, okay? And you do things that look a lot like this with some of this. You're on the thing. Run for 2 minutes on the treadmill. Make sure your heart rate's at a certain place. Track it while you're going, okay? Then you're going to rest for a minute. Then we're going to do 30 seconds as fast as we can go. And then rest for a couple of minutes. And then back to this. It's all the same thing, okay? A lot of modern exercise programming, especially if you're going to pay somebody to do Peloton, whatever it is, does a lot of these things. It's not this. It's not go run for half an hour at a comfortable pace. It's not just go ride your bike, okay, at a comfortable pace for an hour. It's these things, right? It's push the intensity as much as we can because we think that's the thing that drives all the adaptation. Just want you guys, when you see and encounter these things, to at least be aware of what it is and why it's at least being suggested as a thing to do. Okay, we're going to take a 5-minute break. At 11:40, I'm going to give out some handouts. I'm going to put up some different things, so my Zoom folks will get involved. I'm going to give you guys some sheets. You're going to get in groups. We're going to put a workout up here, and you're going to outline on that sheet for me frequency, intensity, time, type. Is there progression? Is there repetition? Is there overload? Is there specificity? Okay? We are going to go through these things step by step by step to see is it meeting the things that we need, right? And is it meeting it in some different kind of a way to be able to get our adaptations to take place? Okay. All right, so 1141.